Okay, in this third video cast, we're looking at balanced versus unbalanced forces. First, a quick review of inertia. An object at rest tends to remain at rest, while an object in motion moves at a constant velocity. That means in a straight line at constant speed. Unless, and this is a big caveat, acted upon by an unbalanced force. It can't be just a force. There has to be no other force canceling that force. It has to be, when we add all the forces together, we end up with some kind of leftover or net force. Okay, so we can start answering questions from there. Number one, the amount of force required to keep an object moving. Right away, we can say that that's F nonsense. There is not a force required to keep an object moving. If it's already in motion, it will continue to move in a straight line at a constant speed, whether we apply a force or not. Okay, so a common misconception is that you have to have a forward force to keep things moving. Not required. Depends on circumstance on whether you'll have to balance other forces out, but you do not need a forward force to make something continue to move forward. It's inertia does that for you. Now, number two, if we see a change in the state of motion, then there must be an unbalanced force. If we see something moving at constant velocity in a straight line, then the forces are not unbalanced. They are what we would call balanced. Now, in this first one, the spaces increase, so that indicates they're getting faster. That's a change of the state of motion, so therefore the forces must be unbalanced. In the second one, the spacing is equal, indicating we're moving at a constant speed, and it looks like we're moving in a straight line, so therefore constant velocity, and therefore no unbalanced force. In this next one, we start out larger, and then we get much smaller. So in that case, we're getting slower. And again, that means, yes, there must be an unbalanced force. We are changing the state of motion. Now, keep those in mind as we try to match force diagrams below to which ones might go above. For this one on the left, we have an unbalanced force to the left, which would indicate that if we're moving to the left, we would be speeding up. If we're moving to the right, we would be slowing down. So this would best match diagram C from above. We are moving to the right. Our velocity direction is to the right, and we're slowing down. This next one has an unbalanced force. See, this one is longer than this one, so we call that unbalanced. That means we would be, if we're moving to the right, we'd be getting faster. If we were moving to the left, we'd be getting slower. So that best matches letter A from above. Now, these four forces, this is exactly what we would mean by balanced forces. For every rightward force, there's an equal force to the left. For every downward force, there's an equal force up. So that's letter B. Now, if the net force acting upon an object is zero, then going back to the review, if it's at rest, it would stay at rest. If it's moving, it would move at constant speed in the same direction. So in terms of using the word must here, the correct answer is E. It's either going to be at rest or it's going to be moving in a constant velocity, which means a constant speed in the same direction. 0 newtons of net force is what we mean by balanced forces. So if the forces are balanced, then there can be no change to the current state of motion. So if we're at rest, we will stay at rest. If we are moving, we will move at a constant speed in the same direction. Okay, so that's what that means. Balanced versus unbalanced forces. Okay, in the next episode, we'll pick up with other ways to look at this idea of balanced and unbalanced forces and keep track of it.